Hello and welcome all dear student in the next video lecture of the topic solid state. So dear student, in the last lecture we have done the derivation of density of a unit cell. Density of a unit cell or a cubic unit cell is equal to rho. Density means the rho, which is equal to m into n divided by a cube into Na, where m is the molar mass of the substance, m means the number of particles per unit cell, and as we know, for the Sc n is equal to 1, for Bcc n is equal to 2, and for FCC n equal to 4. Divided by a cube. A is the age length of the unit cell and Na means the Avogadro's number, which is equal to 6.022 into 10 raised to 23 number of particles. So that part we have covered. That means the relation between density, molar mass and the age length of the unit cell we have discussed in our last lecture. So dear student, dear friends, in this lecture we are going to study the packing of the particles in crystal structure. How the particles are packed when the crystal structure or the crystal lattice are formed. So as we know, the base is followed by the lattice, it forms the crystal structure, or it forms the crystal structure, that means a crystalline solid. And in the crystalline solids, the particles are very closely arranged, closely packed in the crystal structure or in the crystalline solid. When the crystal structure are formed, the lattice or the base is followed by the lattice, it forms the crystal structure, and lattice means the three-dimensional arrangement of the point in a space. The three-dimensional arrangement of the point in a space called as a lattice, and the base is followed by the lattice, it forms the crystalline solids or the crystal structure. And in the crystalline solids, the particles, the constituent particles means the atoms, ions or molecules are closely packed. And therefore, when we have to describe the close packing of the particles, then the particles are considered as a spheres. Means here, this is one of the spheres. And when we describing the closest packing of the particles, when the crystalline solids are formed, then that particles is considered as a hard sphere, just like this. Means one particle is considered as a one sphere. One particle is considered as a one sphere. So we have to remember that while describing the crystal structure, the particles are considered as a hard sphere. So here, first, when the packing of the particles in the crystal lattice are done, then first we come to know about what is mean by coordination number. And as we discussed, the particles are considered as spheres, like this. The particles are considered as a sphere. So, when the crystal structure are formed, but before that, we come to know about the coordination number of a sphere or a particle. So, what is mean by coordination number? As we know, when the crystalline solids are formed, when the crystal structure are formed, then they are very closely packed. Then at that time they are very closely packed. and therefore if we have one particle, that means one sphere. If we have here a one sphere, then or one particle is considered as a sphere in this closest packing structure. Then what is mean by coordination number? Coordination number is the number of sphere touching to any one of the single sphere. What is mean by coordination number? Coordination number is the number of sphere touching to any one sphere. So if this is one of the sphere and if it touches the four sphere, if it touches the how many sphere? The four sphere. So this is the middle sphere, or this is A, what we call it as A. Then what is the coordination number of A? By the definition, coordination number is the number of sphere touching to the single sphere, to any given sphere. दिलेल्या स्पियरला म्हणजेच पार्टिकलला किती स्पियर किंवा पार्टिकल टच होत आहे, अटॅच होत आहे, तो म्हणजे त्याचा कोऑर्डिनेशन नंबर. तो म्हणजे त्याचा काय असेल? कोऑर्डिनेशन नंबर. सो इन दिस स्ट्रक्चर व्हॉट इज द कोऑर्डिनेशन नंबर ऑफ ए? द कोऑर्डिनेशन नंबर ऑफ ए इज 4 because the four sphere are touched to that single sphere A, and therefore the coordination number of A is 4. The coordination number is the number of neighboring sphere that touch any given sphere is called as a coordination number. So when we have a close packed structure, then at that time we have to study about the first one, the close packing in one dimension, then the close packing in two dimension, and then the close packing in three dimensions. When the crystal structure are formed, that means the crystal structure always it is a three-dimensional structure. But when a closest packing structure of the crystalline solids are occur, then we come to know about the close packing in one dimension first, then the close packing in two dimension, and then we have to study the close packing in a three dimension. But before that, all of you have to understand what is mean by coordination number. Coordination number is the number of neighboring sphere that touches a single given sphere. That means this is the coordination number of this sphere. Sphere means it is considered as a particle, or the particle is considered as a sphere here. And therefore, first of all, we have here the close packing in one dimension. As we discussed in our second or third video, what is mean by one dimensional arrangement? One dimensional arrangement means here this is our x axis, and it is a one dimension structure. In a one dimension means first how the spheres are packed in one dimension. That means the close packing in a one dimension. So if we consider the one dimension structure, then here we have a sphere only in one dimension, and they are arranged in a row only, in a single row. This is the one dimensional structure. So here we have a one dimensional structure here. That means only along with x axis or y axis or a z axis. So this is the one dimensional close packing. So if means in a one the sphere are attached only in a row, only in a one row. In a one dimension, it is attached only in a one row. That means here. If we have to find out the coordination number, if we have to find out the coordination number of any one of the sphere, then what is the coordination number of this sphere A? Because this sphere A, it is attached to any, how many sphere? These are attached to only two sphere. These and these means they are attached only two sphere. So what is the coordination number of this A? Is 2. Coordination number means neighboring sphere are attached to that single sphere. And in a one dimensional closed packing, what is the coordination number? The coordination number is always 2. If we have, this is the sphere B. So what is, this is also sphere A. Then what is the coordination number of this sphere? Means this is attached to how many sphere? They are attached to the two sphere. Therefore, the coordination number of this sphere is also 2. That means in the one dimensional structure, except the end sphere, always remember that, except the end sphere, that means these two sphere. These are one end and this is another. Then what is the coordination number of this sphere A? Then it is coordination number is only 1, because here there is no any one sphere is present. Therefore, only at the end in a one dimensional structure, what is the coordination number of the end sphere? It is 1. Otherwise, in a one dimensional structure, the spheres are arranged in a one row. The spheres are arranged in a one row, and therefore the coordination number of each sphere except the end sphere are 2. So this is a close packing in a one dimensional structure. Then the second one, the close packing in a two dimensional structure. Suppose this one dimensional structure, so in this one dimensional structure here, if we have a one dimensional spheres here, if we have here a one dimensional sphere, then what is the coordination number of this one dimensional sphere? The coordination number is 2 except the end. So these are the trough. In the physics, we well known about the waves. Waves, they are having crust and trough. But here we have, these are the trough and these are the depressions. Trough, depression. These are the T. T means the trough, and these are the D. D means the depressions are present. So these are the depressions, these are the depressions, and these are the trough. Means when the spheres are attached in a row, they are having some trough and the depression, trough and the depression. But in a close packing in a two-dimensional structure, then the structure, a close packing in a two-dimensional structure result by the stacking of the rows together, that they are in contact with each other, and therefore there are two ways to obtain the close packing in the two dimension. There are two ways to obtain the close packing in a two dimensional. The first one is a square close packing. The first one is a square close packing. What is mean by square close packing? If we have a structure, that means if we have a one-dimensional structure here, if we have a one-dimensional structure, and in that one-dimensional structure, suppose this is the arrow. What we call it as an arrow. And on the trough, on this part, if we have a second sphere, means on the trough, if we have here stacked the second sphere, each and every sphere, on that trough we have stacked the second sphere. So again here we have stacked on the trough the second sphere, then it forms a square closed packing. Means on the trough here we have a trough of another sphere on this trough. On the third, on second, fourth, on third. So this is first type of closed packing in the two dimension called as a square packing. Square packing means suppose this is the arrow and this is also A. We have a model of this structure. Square closed packing in the two dimension. That means, dear student, here we have these square closed packing arrangement in the two dimensional structure, because in the two dimensional structure we have two types of a two dimensional arrangement. The first one is a square closed packing. That means here we have to clear that this is the arrow, these are the trough and these are the depressions. All these are the depression. But here the second row is stacked in the trough on the first row. The third row is tapped in the trough on the second row. The fourth row is on the trough of the third row. So the second row is not present in the depression, it is present on that. Therefore this is a type of arrangement. This arrangement is called as a type of arrangement in a two dimensional closed packed structure. This is a type of arrangement in a closed packed structure. Why it is called as square packing closed packed structure? Why it is called as a square closed packing structure? Because if we see here, then what is the coordination number of these spheres? Suppose this is one of the sphere, then what is the coordination number of these sphere? Coordination number means this single sphere is attached to the how many sphere, and this sphere is attached to the four another sphere. That means this structure is like this. That means if we have this sphere and this sphere is touched to how many sphere? These are touched to the four sphere and it forms a square. It forms a square, means the packing is a square closed packing. So this packing is called as a square closed packing. In a square closed packing, that means in a type of arrangement. Here the second is present on first, the third is present on the second, and fourth is present on the third, and so on. This is a two-dimensional structure. X-axis, Y-axis. This is a two-dimensional structure of the square closed packing. But in a two-dimensional structure, here we have a second type is called as a hexagonal closed packing. Here we have a second type, it is called as a hexagonal closed packing. In hexagonal closed packing, suppose here we have a type of arrangement. So these are the trough and these are the depressions. So these are the depressions. These are the depression. If the second layer is present not on the trough but it is present on the depression, that means here this second layer is present on the depression. Here it is present on the depression. Then the third is like A, third is like here A, This is not A because it is present not on the trough, it is present on the depression. Second layer is present on the depression, so it is called as B. But here the third is like A, here it is B. So this type of arrangement in a two dimension is called as a hexagonal closed packing. Why it is called as a hexagonal closed packing? We have a model of also structure. This is the model of this structure. So this is also two-dimensional structure, but in that two dimension, this is the first row, this is the trough, and this is the depression. But the second row is not on the first row; it is on the depression of the second row, on not the trough. It is on the depression. The first row and third row are similar, and the second and fourth are similar. So these two type of or these two dimensional structure is called as a hexagonal closed packing. Why it is called as a hexagonal? Because if we see the coordination number of the any one of the sphere, then it is equal to, coordination number means this single sphere is attached to how many spheres? It is attached to 1, 2, 3, 4, 5, 6. 6 means hexagon. So this two dimensional AB type of arrangement is called as a hexagonal closed packing structure. So in this, suppose if we having this sphere, then these sphere they are attached to how many sphere? They are attached to the 6 sphere form the hexagon, and therefore this structure is called as a hexagonal closed packing structure. Because so these are the two structure. These two structure are two dimensional, but according to the arrangement of the rows in one above another, there are two types of two-dimensional structure of the two dimensions. Here the closed packing in the two dimension, this is the AA type of arrangement, and this is a AB type of arrangement. It is called as a square closed packing arrangement. It is called as a hexagonal closed packing arrangement in a two dimensions. Both these are the two-dimensional structure, remember dear student. But here the arrangements are similar. Here the arrangement of the two rows, first alternate rows are same. Because the second row is not present, just like this, it is present on the trough, means it is present on the depression of the first row. So what is the coordination number of these? The coordination number of these square closed packing is 4, and the coordination number of these hexagonal closed packing is 6. So dear student, here in this today's lecture we have completed the packing of a crystal, packing of a particle in a, here we have completed the packing of a particle in a crystal lattice. In that the particle is considered as a sphere because the crystalline solids are formed by the closed packing, and therefore the particle are considered as a sphere. And in a one dimension closed packing, the coordination number is 2. In a two-dimensional structure, here we have a two types, square closed packing and hexagonal closed packing. In the square closed packing, AA type of arrangement, the coordination number is 4, and in two-dimensional hexagonal closed packing structure, the coordination number is 6 here. So these are some models and figure as I shown you here. So the packing in the 3 dimensions or the closed packing in the 3 dimensions, that part we have covered in the next lecture. So dear student, in today's lecture we stop here. We will meet in the next lecture. Till then, thank you.